Okay, so just so you have a point of reference for this lesson, I just want to go ahead and show you a dance because I am the best dancer that you've ever seen. This dance is going to help you with transformations and understand just how to graph some things a little bit more simply for now and for Algebra 2. So the dance that you need to know, you're going to put your hands right here. It's like parentheses, right? So on the inside, we shake our head left to right. On the outside, we go up and down. Inside, left to right. Outside, up and down. And what that's going to tell you is that on the inside, all right, you want to think about it. First of all, you're shaking your head left to right, so that's the direction that that's going to move you. And you're saying no. So on the inside, we're going to think opposite. On the outside, you're moving your head up and down, so that's going to be Y. You're going to be moving up or down, and you're going to be thinking the same because you're telling yourself yes. So inside's opposite, left to right. Outside's the same, up and down. All right, so now that you have that dance in your head as a point of reference, let's go ahead and take some notes on paper so you have something to look back to. So this is section 1.3 about function transformations. This is going to apply to basically, if you kind of think about that wall in my classroom where we have those like 8 or 9 different functions, this applies to every single function you will ever deal with. And we're going to deal with all of those this semester, so it's good to know them. So the first thing I want to make a point of, you can go ahead and copy down these notes. Notice here that I've said grouping symbols. So in the video, I referred to parentheses because when you do quadratics, you use parentheses to do that. But grouping symbols could be anything. It could be absolute value bars. It could be square root symbols. What are some other ones? It could be like a big fraction bar when we do rational functions where it has like x plus 2 over 7. I mean, it can be anything there, right? So just keep that in mind that it may not always be parentheses when you're looking at it. So the basic thing that you need to write down from the dance is probably that the inside, so inside that grouping symbol is going to be horizontal movement, and it's going to be opposite. And then outside are my vertical movements, and they're going to be the same. And I'm going to show you a few specific examples just to refer back to during class. All right, so the first thing is translations and shifts. And if you remember from geometry, translations and shifts are just when you take whatever the figure is, the graph, the function, what have you, and you literally just kind of slide it over, left or right, up or down. And you could do a combination of those. So they come from addition or subtraction when you're looking at the function. So let's say that our original function is f of x. All right, so a few examples here. So notice in this first example, I have f of x plus 2 on the inside. So remember, inside is horizontal, that's left and right, and I want to think opposite. So that plus 2 is really going to move me, instead of moving me right, it's going to actually move me left by 2. So you would call this a shift left of 2. The one below it, all right, we're still on the inside, so we're still thinking left to right, and we're thinking opposite. So minus 4 really means to move right 4. So we're going to call this a shift right by 4. On this other side, we have numbers that are on the outside. So when I say on the outside, I mean on the outside of the parentheses, right, on the outside of that grouping symbol. So on the outside, we're thinking vertically. We're moving up or down, and we're going to think the same. So for both of these, the signs are going to match what you think. Plus 3 in the vertical direction is going to mean to shift up by 3. And then minus 5 in the vertical direction is going to mean to shift down by 5. All right, so remember that dance is really going to come in handy just when you're kind of thinking in your head, where are the values that you're dealing with and what are they going to be doing to the function? All right, the next thing that could happen to a graph would be stretches or compressions. And when I think about stretches or compressions, I kind of like to think about a rubber band, like if you just pull it in one direction instead of making it, pulling it wider in all directions, you're just pulling it up, or maybe you're just pulling it side to side. This is going to come from multiplication, and it's going to come from values, numbers that are greater than 1. That generally results in a stretch, but we'll talk about that. And then also numbers that are, I didn't want to say less than 1 because it doesn't come from negative numbers, it comes from fractional numbers. So numbers that are between 0 and 1. All right, so let's look at a few of those examples. All right, so this first example, we're on the inside, so we're thinking about effects horizontally. But inside is the opposite. So for instance, this is a 2, but I want to think opposite of that. And this is a little tricky. So since this is multiplication, the opposite of multiplication is really the division. So instead of changing the sign, I'm going to use the reciprocal, which means this 2 on the inside, I need to really be thinking about it like a 1/2. So this is going to be inside is horizontal, so this is going to be a horizontal. Since it's really 1/2, this is really going to be a compression. So we're going to say horizontal compression of 1/2. All right, let's do this other one. On the inside, again, we're thinking opposite. We're still horizontal. So I know that this is horizontal, but since I'm thinking opposite, that's really a 3. So a 3 is going to stretch. So I'm going to say a horizontal stretch of 3, because now 3 is a number that's greater than 1 when I think opposite. All right, on these other 2 examples, the 4 is on the outside here. So 4 on the outside is going to tell me vertical. And vertical, I get to think the same. So this is going to be a vertical stretch, because 4 is a number greater than 1 of 4. And then with the 1/5, it's really similar there. This is a vertical stretch. Oh, what am I saying? Not stretch, vertical compression of 1/5, because outside is the same. Now, I will give you just kind of a sidebar. This can be a little trickier as far as graphing and just kind of understanding what you're doing. So I'm going to have you make one note here, and then we're going to practice this note in class when we actually have some graphs to work with. All right, so I just want you to keep in mind, you're going to be thinking about the slope. Slope is rise over run, so that's vertical over horizontal. And what I'm saying to you is, when you have these horizontal compressions, you're affecting the run part of your slope, but not the rise. Okay, the run will be affected, but not the rise. When you do a vertical something, stretch or compression, you're going to be affecting the rise, but not the run. All right, so it should only affect either rise or run one at a time. You generally don't affect both of them. And we'll get practice with that in class. All right, the last transformation are reflections. These are going to come from multiplication by a negative number. So there's really only 2 options. Now, I will say I'm showing you multiplication by just -1. It could be by any negative number, but any number other than 1 is also going to result in that stretch or compression that we just talked about. So I'm just kind of keeping it as basic as I can for your notes. So here on this first one, we've got the negative on the inside, which is supposed to make me think horizontal. And so what that's going to do, on this one actually I am going to show you a picture. For example, if the function was an f, I'm going to flip that horizontally, or reflect it horizontally so that it turns this way. And if you think about that, you're reflecting horizontally, but you're really flipping over this vertical line. So this is going to be a reflection. We're going to say over. Sometimes they say about, but over makes the most sense. Over the y-axis, because that's the thing that you're flipping over from left to right. On the outside then, we're going to be flipping up and down. So think if you flip something up and down, right? If I have a U and I want to flip it upside down, that was difficult to draw. I'm flipping over the x-axis, so this is going to be a reflection over the x-axis. All right, those are the notes that you need for class tomorrow, and we will work together to work on how to graph those.